All right, so we're continuing on with this composition of functions, which is very important. So given this capital F of x, I would like you to create a f and a g, a little f and a little g. I can't have either of them be equal to x, so that it gives me this. So I see the outside function f of x as being e to the x, and the inside function being 5x squared. In this particular case, sometimes there can be more than one, could be more than one in this one, but I'm just going to go with the straightforward 1 over x being the outside function f of x, and the g of x function being x cubed plus 4. This one here, I want to make sure you know this is the same thing. I could rewrite this as secant of x all squared. So my outside function f of x will be x squared, and my inside function is secant of x. This one here, this could be rewritten as cotangent of x to the 1/2, right? Or square root of x. You can keep it that way. But so the outside function would be the trig function, and the inside function would be the square root of x. All right, so continuing on with that same idea, now we have 3 layers. So I'm going to start with this one here. So the most outside function is ln of x. The next layer would be 1 over x, and the most inside function would be x plus e. This one here, the most outside function, again, this cubed here, let me just take the moment to rewrite this. This cubed means the whole trig function is cubed. So I'm going to make that the most outside function. The g of x will be the next layer, which is cosecant of x. And then the h of x will be the e to the x. This one here, the most outside function is cotangent of x. The next inside layer will be ln of x, and the h of x will be pi x, the inside layer. All right, so we are going to be dealing with this difference quotient. So this is called the difference quotient. We'll find out what the meaning of it is shortly, but let's figure out what this simplifies to using this function. So first off, let's just make sure that we're clear on what f of x plus h means. So this says substitute in x plus h everywhere there's an x, correct? And then f of x is just x squared minus 3, right? Okay, so let's do this. So f of x plus h, I'm going to be substituting this in, right? So I'll have x plus h all squared minus 3. Okay, then I'm going to say subtract, right? Subtract, and let me get a different color going on here. So subtracting f of x. So subtracting, and I'm going to put parentheses here, f of x, which is that. And I'm going to put it all over h. All right, so this will simplify. I need to multiply this out, and you know that this is 2xh plus h squared minus 3 minus x squared plus a 3 all over at h. So I see some canceling going on here. And then the x squared's canceling. All right, so after canceling, I get 2xh plus h squared all over h. Okay, so now be careful with the canceling. If you see there's h's to cancel, I need to factor the h out of the numerator, and then I can cancel these h's. So my answer is 2x plus h. And I'll do the next 2 examples in the next video.